Good morning. Today we are working on math lesson 612, and our math message for today says, use a calculator to solve these problems. Record a number sentence for each problem. Then you're supposed to think about the patterns that you notice. I would pause the video and attempt to do that for each one of these problems, then press play when you're ready to go on. So here we have the answers to each one of the problems that we had in our math message. What kind of patterns do we notice? Notice that the problems all have a 2 in the dividend, which is the first number in each of these equations. They each have a 2 in the dividend, and they all have a 1 in the divisor. You can see that in each one of those. But the decimal point is in different places. All of the problems have the same quotient or the same answer. You can see here the answer to each one of these is 20. Now you might be surprised that 20, the quotient for the first two problems, is greater than what we started with the dividend. The reason this makes sense is because the one way to interpret a division problem is to think, how many of the divisor are found in the dividend? For example, in our second problem right here, you could think of it like this. How many tenths are in the number 2? So 2 divided by 1/10, I know that there are 10 tenths in 1, so there would be 2 times 20, or 20 tenths in the number 2. So you could extend this thinking to explain why 2 tenths divided by 1/100th equals 20. Each tenth has 10 hundredths, so there are 2 times 10, or 20 hundredths, in 2 tenths. So that's how we get 20 for this problem right here. Now, examine the dividends and the divisors in each problem. How do the dividends change from problem to problem? So that's your first number in each of these number sentences. How do they change from problem to problem? The decimal point moves one place to the right, which means each dividend is 10 times as large as the dividend before. Now, how do the divisors change from problem to problem? The decimal point moves one place to the right, which means each divisor is 10 times as large as the divisor before. So from problem to problem, the dividend and the divisor were both changed in the same way. They were each multiplied by 10. So making the same change to both the dividend and the divisor did not change the quotient or the answer. Now, remember that every fraction can be interpreted as a division problem, and every division problem can be interpreted as a fraction. For example, look at the top of this page where I have 5 divided by 8. We can say that the answer is 5/8. So how could we write 2 divided by 1/10 as a fraction? We could write it as 2 over 1/10. So that's written as a fraction. How could we write 20 divided by 1 as a fraction? We could write it as 20 divided by 1. Now, what do you notice about these fractions? These two fractions are equivalent. Remember, we've used that word before when we talked about fractions. They are equivalent. How do you know that they are equivalent? If you multiply the numerator and the denominator of 2 over 1/10 by 10, you get 20 over 1. So if I multiply both of these numbers by 10, 2 times 10 is 20, and 10 times 1/10 is 1. So that's how we know they are equivalent problems that can have the same answer. Creating an equivalent problem can be useful when solving decimal division problems. Today we're going to apply what we know about equivalent fractions to generate equivalent problems. What rule do we already know for generating equivalent fractions? Multiply the numerator and the denominator by the same number. When we write a fraction as a division problem, where do we write the numerator? That becomes the dividend. Where do we write the denominator? The denominator is the divisor. How could we use the rule for generating equivalent fractions to generate equivalent problems? We can multiply the dividend and the divisor by the same number, just like we multiply the numerator and denominator by the same number. Okay, we already have strategies for solving decimal division problems with whole number divisors. One way to solve problems with decimal divisors is by thinking about equivalent problems that have whole number divisors. So here you see the problem 3 divided by 2/10. So what is the divisor in this problem? Well, the divisor in this problem would be 0.02. By what number could we multiply 2/10 to get a whole number? We could multiply it by 10. Okay, what do we get when we multiply 2/10 times 10? We get the answer of 2. Now we have a whole number. What else do we need to do to make our new problem an equivalent problem? We need to multiply the dividend by 10 also. So we're going to multiply the dividend by 10 also. So what is 3 times 10? It's 30. So what is our equivalent problem now? Now our problem is 30 divided by 2, which we all can do that in our heads. What is 30 divided by 2? It's 15. So now, what is 3 divided by 2/10? The answer is also 15. Why are those answers the same? How many groups of 2/10 are in 3? There are 5 groups of 2/10 in 1, so there are 3 times 5, or 15 groups of 2/10 in 3. This is another way to show that the answer is 15. Okay, now think about how you might use an equivalent problem to solve 8 divided by 2/100. First of all, we can multiply the divisor 2/100 by 100 to get the whole number. Multiply this by 100 to give us the whole number 2. Okay, 2/100 times 100 is 2. We're going to multiply the dividend 8 by 100 also, because we have to do that to the dividend as well, to get 800. So now we have 800 divided by 2, which equals 400. So that tells us that 8 divided by 2/100 also equals 400. Would it have helped to create an equivalent problem by multiplying 8 and 2/100 by 10? Why or why not? Well, the answer is no, that would not have helped us, because the problem would become 80, if we multiplied it by 10, divided by 0.2, which is still a decimal divisor. So what makes 800 divided by 2 easier to solve than 80 divided by 2/10? 800 divided by 2 has a whole number divisor. It is an extended division fact. The point is to create equivalent problems with whole number divisors so that you can apply the division strategies that you already know how to do. Let's look at a few more of these problems. So 4 2/10 divided by 7/10, we can multiply each of these numbers by 10. So 4.2 times 10 will give us 42. And 7/10 times 10 will give us 7. Then we all know that we can do in our head 42 divided by 7, which equals 6. So the answer to 4 2/10 divided by 7/10 is 6 because those are equivalent problems. Okay, let's look at the next one. 3 9/10 divided by 3/100. We can multiply each of these numbers by 100. So 3.9 times 100 is going to give us 390. And 3/100 times 100 is going to give us 3. So then we can take 390 divided by 3, and the answer is 130, which is also the answer to our original problem, 3 9/10 divided by 3/100. So you can see it's much easier to convert these to equivalent problems to divide the decimals. Let's look at the problem 4 68/100 divided by 1 3/10. What should we multiply the dividend and divisor by to make an equivalent problem? Let's try multiplying them by 10. If we multiply 4 68/100 by 10, that will give us 46 8/10. And then if we multiply 1 3/10 by 10, it's going to give us 13. Now, we have the equivalent problem 46 8/10 divided by 13. Now, this is a different kind of problem than what we just solved because our dividend still has a decimal in it. But remember that we already learned a method for solving division problems that have decimals in the dividend. So we're going to make an estimate to solve the problem as if the dividend were a whole number, and we're going to use that estimate to place the decimal point. So we are going to make our estimate be 46 divided by 10. So we can round the 46.8 down to 46. We're going to make this 10 to make it an easy number to divide with. That's going to give us an answer of 4 6/10. Now, we divide as if 46.8 were a whole number, so 468 divided by, this is how we were doing these problems before, divided by 13. We're going to find that 13 goes into 46 3 times. It's 39. We're going to subtract. 7, 78. That is going to be 6, 18, 78. So our answer is going to be 36. So then we're going to go back and look at our estimate to see where to put the decimal point. Our estimate up here was 4.6, so that means I'm going to put my decimal right here in between to make it close. So now my decimal is 3 6/10. So in other words, 46 8/10 divided by 13 equals 3 6/10. So 4 68/100 divided by 1 3/10 also equals 3.6. Okay, now in your module, I had made a copy of Math Journal page 227, and at the top of that page it says for problems 1 and 2, write an equivalent division problem that has a whole number divisor. Be sure to multiply the dividend and the divisor by the same number. Make an estimate for your equivalent problem. Divide as if the dividend were a whole number to solve your equivalent problem, then use your estimate to place the decimal point. Complete the number sentences to show the answers to the equivalent problems and the original problem. Okay, for Math Journal page 227, number 1, the problem is 2 79/100 divided by 9/10. We're going to multiply each of those numbers times 10. So our equivalent problem is going to become 27 9/10 divided by 9. We're going to make an estimate, so we're going to round 27.9 to 28. And then let's just round the 9 up to 10, make it easier to work with. So our estimate's going to be 29 divided by 10, or 28 divided by 10, I'm sorry, which is going to give us an answer of 2.8. Remember, that's our estimate. So now our equivalent problem with the answer is going to be 28 divided by 10 equals 2.8. And I'm sorry. Let me erase that. I missed a few lines that are in my book and not in your copy of the paper. Okay, so our equivalent problem with the answer would be 27.9 divided by 9 equals 3.1. And so that also tells us, since it's an equivalent problem, that 2 79/100 divided by 9/10 is 3.1. Okay, for number 2, the problem is 85 4/10 divided by 14/100. So first, for our equivalent problem, we're going to multiply each number by 100. So let me show that up here. We're going to multiply each number by 100. So that will make our equivalent problem 8,540 divided by 14. Okay, that's our equivalent problem, so it's equal to what our original problem was. For our estimate, I'm going to round that up to 8,500. Hard to read this sometimes. Divided by 10. We're going to change our 14 to 10. So that's going to give us an answer of 850 for our estimate. Okay? So now for our equivalent problem with the answer, we had 8,540 divided by 14 equals 610. So the answer to our original problem, 85 4/10 divided by 14/100 is 610. Okay, so for your work today, you need to complete Math Boxes 612 and HomeLink 612. Then I also have attached in your module a review sheet, because on Thursday we're going to be taking a quiz over these lessons in Unit 6 that we have done. It won't be near as big as our usual tests, so we're just calling it a quiz, and you'll have one day. Tomorrow we'll go over that review sheet together, and then I will also be available tomorrow afternoon for a Zoom call from 1 to 2. So if you have questions over the review or anything like that to prepare for the quiz on Thursday, you'll have an opportunity to do that. So once again, Math Boxes 612 and HomeLink 612, and do that review sheet that you find in the module as well, and I will see you tomorrow.